Video 5, Deep Underground Concept, Part 2. What is the amount of material we are talking about? The deep underground concept needs to excavate an average of 1.5 centimeters from the boundary each day to achieve the same excavation time as the conventional method. This means that in the beginning, an excavation surface of 31.4 square meters should be obtained in 24 hours and around 0.54 cubic meters excavated. For the final 1.5 centimeters of a 3-meter diameter shaft, a surface of 963 square meters should be obtained in 24 hours, and 14.1 cubic meters of excavated material should be removed. Since the material consists of small particles, it can be transported to the surface with a small pump or ventilator at the bottom. Similar considerations apply to tunnels, with a daily advance defined at 10 meters for conventional construction. This means a 100-meter, 3-meter diameter tunnel can be excavated in 10 days, 10 times faster than according to the deep underground concept with the assumed advance. This issue will be addressed in one of the next episodes. For now, it's important to remember that the deep underground concept offers a much larger excavation face than conventional excavation, over 4 times bigger at the beginning and more than 135 times bigger at the end compared to conventional underground construction. Relatively small excavation advances, 1.5 centimeters a day of the borehole boundary, can match the same speed of shaft excavation as with conventional methods. The volume and weight of excavated material are relatively small. They range from 0.5 cubic meters per day to a maximum of 15 cubic meters per day, or expressed in weight units from 1.3 to 35 tons per day. A borehole of 10 centimeters doesn't offer a lot of space. Therefore, the amount of material excavated from small diameters must be small. Since the excavation should be carried out continuously, hourly excavation rates for a small diameter hole are estimated as low as 0.024 cubic meters, or 50 kilograms of material per hour, to match a daily advance of 1.5 centimeters. When the diameter is bigger, there is more space to obtain the boundaries in the desired manner, and the excavation is easier. When the diameters are small, the excavation is more challenging, but since the amount of material that should be excavated at that stage is relatively small, the problem is easier to solve. Since the material should consist of small particles and the amount is small, it can be transported to the surface with a small pump or ventilator at the bottom of the borehole, which is crucial due to limited space. The next video will present some candidates capable of performing excavation in the preferred way.